Oh, sorry for that. Welcome to the stream. Today, as always, we'll be doing the Voxel project Voxel, and we'll be creating something that is, we could say, how could I say it, like that's something is not necessary for every project that would use project Voxel, because all the previous parts would be necessary for nearly every project, but today we'll be doing well, better. What I was supposed to say? Better voxel types. So, for example, instead of having just a enum of types, we'll have a proper classes that will implement some functions for rendering, all that stuff. It will slow down a bit our code, but I think for some types of projects it will be just necessary to make it. So yeah, let's get to work. Obviously I commented all the stuff that was not commented before, like the chunk stuff. You can find it all on GitHub. And I still didn't manage to find how to add links to Twitch, so I'll just post the links where you can find me in the chat. So you can check out my YouTube channel here, where are just the past live streams, and you can find my GitHub, or rather GitHub to this project here. But right now, let's get to work. Okay, so first I will create another folder inside because we need some better organization in the project, and we'll call it Voxels. And also we need a new script called Voxel base. This script won't be a mono behavior, but will be marked as abstract. Abstract means that we can only inherit from it, and we cannot create instance of this class. Then this class will have a function, abstract function. Oh, abstract also gives us the ability to add abstract functions. Public abstract void, not void, public abstract I enumerable of vector 3 not numeric unity engine, create face, and sorry for that, create face, and we'll pass it a what will we pass? I think that's a face. So just a voxel face. Face. And abstract method doesn't have a body, they only have like the header, I think it's called, and we'll implement it in the classes that will inherit from voxel base. We also need another abstract function will give us a bool. And oh, I messed up. I want to just do virtual function, not abstract function. Yeah, and this will have this will be the function we call when we want to get how to render given face. So want a virtual, because that means that we don't necessarily will render the wait. That means that the other classes won't necessarily override this function. They can just use the default, and the default will be just a block. Okay. For now, that's it. And we also need let me just check something before we go further. Because I think we'll be using texture atlases. Just give me a second. Advanced. Well, I have no idea how to use the Unity Texture Atlas, so we'll just do our own. So I don't care. Okay, let's get back. Sorry for that. Well, whatever. Let's get back to business. Okay, and the second function will be public virtual bool. I'll should always render, and we'll take a face and return a bool, and we'll just for now return always false, and it just basically means should always render this face. So for example, if we would have like two faces that should only be rendered when there is empty block, and there are faces that should be rendered always for some reason, this will be the function. And the third one will be public virtual bool, and we'll call it should always render enable. Because I don't have an idea how to name it. And return false. And that basically means that if we set it to true, no matter, even if this block is there, the neighbor should be rendered. I think that will how it work. We'll see when we get there. So this will be our base the voxel base, and we'll use it as our, let's say, info class. Wait a second.
You only had one.
Okay. Huh. That's interesting. Okay, never mind. Let's get back. Okay. Now we have to use somehow the voxel base, and we don't care about the children of this class. It will come later. So, in the render data, no, in the mesh creator, we have this class face to vertices. We will basically remove it. Oh. And the create face. Okay. In the voxel base, instead of the create face, we don't need create face. We need the create face should create all the whole face. So let's create another protected virtual, and this will be this class, this function. Wait. Let's copy it from this, paste here, and do the enumerable of vector 3, and this will be get vertices. I will just do it get cube vertices, and this will be the base. Like, you can use it but you don't have to. And there, instead not the face, we also pass the vector 3 position, and all the lists. But instead of passing all the lists, we just create another class that will hold all of it. So class mesh data. So it will be less clutter for us. Okay. Mesh data, public list of vertices. So vector 3, vertices equals new. Yeah. Public. I can make it with uppercase and make it a get private set. Yeah. Public list of int triangles. Get private set equals new list. Yeah. Public list of vector 3 normals. Get private set equals new list of vector 3, and public list of vector 2 UVs. Get private set equals new list. Okay. That will be it. So now we'll pass a mesh data, and this should, as the base, we'll just copy the mesh creator, like this function. Voxel. Yes, this one. Obviously we don't have the type to UV base, but we'll do that in a second. Okay. Now, we don't have face to vertices, we have get cube vertices, and want to offset them. That's correct. mesh vertices data dot vertices. We can just do this mesh vertices data dot vertices. Vertices, okay. Replace. Did we spell it wrong? Yes, we did. Like that. Okay. No. Wait. Where am I? Okay. Oh, yeah. Face. We don't have face direction, but we can do it in mesh creator with face direction. We want to change this, so this is data.normals, data.triangles, we will create, and we will create this in a second, so we can just do yeah, we'll do this in a second. Okay. So for now there will be no textures. Yeah, we can do this static, whatever. Should always render false, should always render neighbor false. Okay, so that's our create phase. Now let's go to mesh creator. We don't need this function anymore, so we can remove this function. Face to vertices is also not necessary. Face direction will leave. Type to UV base is also not necessary. Get opposite face is necessary. Okay, so these two will be necessary, and we can remove the texture dimensions. Okay. And instead of create face, because we will be changing this. Okay, now we want to the voxel base will be just a give me a second to think. How can we do that? Could we? Yeah. Whatever. Yeah. Okay. So, our voxel base will be also like the thing that is actually sitting in like the voxel, actual voxel. So it won't need the position actually, because it will have the position, because it will have a public vector3 position get have just a get, so this will be just the position. Okay, and I think that's it. That's all it will have for now, because right now we don't need anything else. Okay, and we also need the constructor. So let's make a constructor public voxel base vector3 int position. And we'll just set to the position equals position, and we can mark it as protected because we cannot do it anyways because it's an abstract class. So that's it. Okay, now let's go to the chunk, because we don't want the voxel type, we want the voxel base to be here. The base, because we don't know what voxel actually will be there. What will be changed? Okay, this will be changed to voxel base. State there will set the voxel should still get the voxel type. So we should have some function that actually changes the voxel type to the actual type. So we'll still use the voxel type, but we'll just and there will be some function will change the type to the actual voxel base type. So let's create another static function. So public static voxel base. Sorry for that. Public voxel base get. Oh wait. Okay. Create voxel. So public. No, not public. What? Not public. So vector print position and voxel type and switch on the type, and this will return null. This will return new something. We can just do nulls for now because we don't have any don't have the classes for that. New exception, wrong voxel type. So yeah, just right now this will be an empty function. We'll make it later. Okay, let's return to the voxel chunk, and this will take a voxel type.state, and we need to somehow check if this voxel base has the same type of this state. So let's add another thing. Now a abstract voxel type will also only have a get. That means that the other classes will have to implement a getter for this, and we'll just implement it as a that will get some value that doesn't change. Okay, now we can go back to chunk and do if the this.position.type equals state. You can put it with type return. Okay, we can do voxel base create voxel position type. Okay, also we have to add the type here. Voxel position render data. What about these? New render data takes the position and the type, and instead of the position and type, we'll just pass the I think also the position. Oh no, because it needs a face. Which face to render? So instead of the voxel render data, it won't take the position and type. Instead, it will take just the voxel base. Voxel. So it won't have the type, it won't have the position. public voxel base voxel and voxel equals voxel. Okay. And we'll just pass the voxel, so voxel's position, just like that. Okay, I think that's it here. What else is wrong? Here is some, okay, try get value. If the relative position out voxel, if not, return null, because null means there's error basically. And we need to change this thing. Okay, this also. No. I mean here. Okay, so this we will have to return voxel base and also return a null. And I think that's it. Only the chunk was wrong in chunk. Neighbor state dot type. So this will be just neighbor to have the state. Oh, you can just do this type, because we don't need the whole neighbor, let's say. And there we need to, instead of the create phase, we'll just do voxel dot create phase. And that, and also needs a mesh data, which we'll create here. So do var data equals new mesh data, yes, like that. Ref data, and this works. And now this we'll just do this data.vertices, data.triangles, data.normals, and data.UVs. Okay, and I hope that will work. I have no idea, but that should work. The problem right now that it won't create anything, so we need at least one voxel type. And where did our here including project, for some reason it went, yeah. And we need a some voxel, so I'll just do iron hull public class iron hull. It will inherit from voxel base. It will implement abstract class. It will return a voxel type dot iron hull, and we can override some functions. No, we don't need. Okay, what's wrong? Oh, and we need also a constructor, right? Like this, and that's it. So now we can go to voxel base, and in the create voxel, in the iron hull, just do new iron hull. We'll also automate this process I hope this stream. And I think that's it. That should be it for now. Let's check if it works. By the way, do we have anything in the voxel map at the start? Iron hull, perfect. I hope it will work. It will probably not work. it doesn't work. Exactly. So what's going on? If this dot position dot type is type, oh, because it's null. Right. So we want to check first if it's null. So this or we could do another thing, because that would make us do a lot of null checks. Instead, we can go to the voxel, create a new voxel. This will be empty. Public class empty, it will be voxel base. Implement abstract class voxel type dot empty. We also need to create the constructor, and the override will be an override like should always render true. Public override should always render, and this will be true. And the last one, create face, it will just return do nothing. So like that it will work. No, just like that. So it will do nothing, absolutely nothing, because we don't want any faces. And we'll just do in the voxel base. We don't want to instantiate the empty every time we want to check something. So we'll just do at the end, why not? Public, no, not public. Private static, public static voxel base empty, and a public static voxel base empty, and this will be a property. So if empty equals null, just empty equals create voxel position whatever vector 3 int 0 evoxel and voxel type empty, and just return empty without the plus. And here we'll just do new empty and the position whatever, we don't care. And that means we'll just have one empty for comparison reasons. And now we can go to chunk, and instead of returning a null, we can just return voxel base dot empty. And do we have a null also in map? Yes. So let's do voxel base dot empty. And now, if we check, that should be working a bit better. Yeah, it's working. Nice. I did what I did with this empty because if we just create every time a new empty object instead of doing this, so making one and just reusing it, you would clog up our memory really fast, because every time we would render something or whatever, we would create a new object. And now we have to fix a couple of things. For example, right here, not in the set, that's all good, but here we check if it's empty, and we don't want to check if it's empty. We want to check if it should render. So we need to get the neighbor, okay, and we need to check if voxel, so voxels position dot should always render face, or neighbor dot should always render neighbor, and the opposite face, so mesh creator dot get opposite face of face, then we should render it. I think that's the only change. Let's see. Yes, it still works, that's good. It creates our big blob. Let's now create another thing that will be somewhat different. So we can do new item. For example, the cobalt one will be like a small one. Cobalt hull. Let's remove this. Public voxel base. Let's implement all the necessary things. Yeah. It will return the voxel type.cobalt hull, and we override the create face, and we'll do it like that. So we can get the base one. So let's get nearly everything the same, but with the vertex position, do it times 0.5 f. And now let's make it like so every face should be rendered. So override should always render true, and override should always render neighbor true, and we'll see how it looks. So let's render, let's make it out of cobalt hull, and I forgot, because we need to also set this. So new cobalt hull position. Okay. As you can see, they are all smaller. And even if we set a bigger block here, it will always render, because we set the face to always render the face. So that is what allows us, that change that we just made, so adding the classes, allows us to do that kind of things, and I think it's awesome. But there are two things that we didn't do. First, this is really bad, because for 4 types it's quite nice, but for for example, I don't know, 100 to 200 types of voxels, this would be really messy. Just a big one function, and it's not a good idea. So let's make a system that will automatically get all the voxels, and then will automatically make this function. So how can we make this? We'll need, I'll just move some stuff to a new class called Voxel Creator or Voxel Helper. It will be a public static function. It will have the create voxel and also the voxel empty. So here we'll remove it. Okay, I can change to empty, I think, because it is empty. Oh no, we can leave it like that. Let's leave it like that. Let's import this. And let's fix the errors. Here not voxel helper, it's empty. And here in the chunk, create voxel helper dot create voxel, and voxel helper dot empty. Okay. Now I'll just close all the documents and reopen them again. Okay, now in the voxel helper we need some function to instead of doing this, we'll do this automatically. So let's make a maybe here private static dictionary that will take a voxel type and return a voxel, not a voxel base, a type. And this will be voxel types equals new dictionary. And we'll make a public static void register voxel type. And it will get a voxel type and or rather voxel type and the type, which will be just a type. And we'll just add to voxel types dot add voxel type dot and type, sorry. And this will just return the register voxel type, no, register type, voxel types of type, and this will return a type, so we need to create one. So activator dot create instance, and we'll use the type and then the parameters, which are objects. So I just add position, and this will just create a new voxel out of this type, and we need to just cast it to voxel base. And that should be it. So now we have this nice register voxel type that will do the work for us. But right now that's not different. We also we would need to register all the voxels manually. So that's not good. Not good either. We need some kind of automation for this function. So let's create another function. Public static void register all voxels. It won't take anything, and we'll do some magic. And the magic is called reflections. And how reflections work? No idea. But they can look into their own code and find different types. So how can we do that? So let's get all types of voxel bases, like all types that inherit from voxel base. So let's do type of voxel base assembly dot get types. It will get all types, and then we want select where x dot base type equals type of voxel base. So that means the base type is a voxel base, and x is class because we want only classes, and x is not abstract. So, and that's the first thing I want to do. Oh, you don't want to select, you want to where. So filter only those. So we have all the types. Then you want to make them into actual voxels. So let's do activator dot create instance of x with position whatever vector3 int x, yeah, like that. So this will create an instance of every class. So now we have the instances, right? But we want to get the type and also this type. So we want, instead of select, we want to do dictionary, and the key will be this. Let's cast it to voxel base. And this is all. This is casted to voxel base. And now we can do type. This will be our key, and then our value will be just the type. So this is our dictionary that should be set here, and we can just do voxel types equals this, and that should be it. I hope. We just have to call the function somewhere, and we'll call it in our voxel map in the awake. So we want to change it a bit. So here we'll do a return, and now we can do all the things that should be done when the when this starts. So let's do voxel helper register all voxels. Let's see if this works. I hope it works. It was just like I came up with this like 10 minutes ago. It works because this works, and it has to work because if it didn't work, that means that this would be empty. That means that this couldn't work, and we couldn't set all the voxels. That's great. Okay. Okay, so we have one thing solved. The other thing that we need to solve is the textures, because right now we don't have any textures. So let's do it. We need another, let's create another class. So voxel, oh not voxel, oh maybe voxel texture helper, and let's do public static, but also it will be static. So we need to gather all the textures in the voxels, then create a big texture out of all of these, and then and then what? Yeah, and that's it. I think. So, first, let's specify the size of the textures. I'll just do 16 by 16. I know my textures are 17 by 17, but I will just do, I just make new ones. So, let's make the texture size. So, public const int texture size x equals 16, texture size y equals 16. So all textures will be 16 by 16. We also need a way to a way to somehow know where they are. We can just make it in the voxel base. So we can do public abstract string texture name and just do a get or other texture path to texture path. Okay, and now we have to add this property here. Let's just do ironhull, just ironhull.png. Empty, we don't care. It can be iron hull, iron. I say the iron right, okay. And empty, we don't care what texture. It doesn't texture, but we still need to. Oh no, what we don't. We just do an empty one. And here, let's make a cobalt. Okay, that's it for now. And now let's make this function. So let's make a public void create texture map. And first we need to we will need to do the texture voxel helper and gather all the voxels. Then we need to iterate through each voxel, and we can do that. So voxel helper public static voxel base I enumerable of voxel base I enumerator, sorry, enumerator. Not enumerable, I want an enumerator because I want to enumerate through them. That will be just memory efficient. Voxel base get all voxels. This won't take anything, and we'll just do yield return. Oh no, sorry. For each voxel in voxel types, we'll just do yield return voxel base and just copy this. Just change it to voxel type dot value. Yeah, value, and the position will be vector c dot 0, not 0, because we'll not care about this position. And if you don't know what a numerator and a yield is, we could return the whole array list, whatever array like object, or we could use an I enumerator. That means we'll return one by one. So we'll return nothing, and then, for example, we place it in for each. And that means that for each will say, okay, give me another one, and then we'll return another one. And after the for each finishes with this one, we'll say, okay, I want another one, and this function will give us another one. And that's how I enumerators work. So we can just do for each voxel in voxel helper dot get all voxels. Oh. Wait, voxel helper, get all voxels. Oh my god. Sorry, I need to do the enumerable. Oh, so I messed up the naming. That's it. Sorry for that. So then for each voxel in voxel helper.get all voxels, we want to get the texture, so var path equals voxel dot texture path, but this is just a relative path. We'll create a folder in assets, or no, let's go to the Explorer. We'll create a new folder outside the assets called textures. You can also do it in asset, that doesn't matter. This is the way that would allow us to change the texture even after releasing the game, so everyone could change the textures. I like this way. If you want, I will show you the way how to load the textures from inside Unity, so no one will be able to change them. So texture path, but I need path to this folder, so this will be application using Unity engine. No, application dot data path, and we'll do path, a big path. Let's import it and combine. I use this instead of plus and slashes because this will always create a proper path and will not depending on the system we are using gaming on. So because Linux uses a bit I think a stricter or less strict path naming, I don't remember exactly. This will just return the correct path always depending on the system. Also we need a textures folder, so textures like that, and this is the correct path to our file. Now we need to open it, so I forgot how to do it, give me a sec. There is some nice library for that, I don't remember. Okay, so bitmap. Let's import it. Oh, we don't have it. I think that should be it, but I don't. I think that should be it. Yeah, bitmap. But I shouldn't have to. Let me do a quick Google search. Okay, we need to use the www class. So var, let's say, call it reader equals new www. I need to pass the path, so path, and we have to add a something to it. So this will be file like this. Now path. Oh, Unity web request, but I don't Unity web request. I want to. I forgot how to do this. Yeah, that's correct. I think that's correct. Now we need to wait for it, so while something like that, but run reader is done, yield return null. But the problem with that is that this is meant to be in a coroutine. That means that it is a special Unity function, and we don't wanna do this. Okay, I found what I want. I want to use a so var bytes equals file dot read all bytes, and now the path, and this is the correct thing I wanted to do. And now we can do var texture equals new texture with the size of text. I knew I missed the texture like that. Yeah, with the size of texture. Oh, it has to be texture 2D because it won't work otherwise. Texture size X, texture size Y. And now we can load it, so texture load image, and this one, and it can take bytes. So bytes, and that's it. So we have a texture now. That's good. We can load all the textures. Now we need to combine them into one image. But we don't want to have one long image, because this could create a problem with floating point operations. We wanted to have it as square as possible. So we can just do something like, we can just calculate the most squarish square shape that we can get. So how can we make that? We can do we can first get all the voxels, so var voxels equals this. Then we can get a count of the voxels, so count equals voxel.count. Then it's a function. Then we can square root it, so var side equals mathf dot sail to int mathf square root of count. We want to set it to int because if we would have like 4.3 side, it would be hard to squeeze a 0.3 image. We could, it's very possible, but we don't want to do this because this could create some problems like missing pixels or whatever. We just want to make it bigger. So if we would have like 15, we would just make it a 4x4 and leave one empty. So now we can go voxels, yeah. So we know the size. So let's create a texture, a big texture that is. Can we make an off here? No. Okay. Now we can create a new texture. So var voxel texture equals new texture 2D int width will be size times texture size x, size times texture size y, and that should be it. And now we'll load the texture, and we need a counter, so let's do int counter equals 0, and we just do var voxel texture set pixels texture get pixels and the and int x will be counter modulo size. Oh, we can calculate it here. So var position x equals counter times size, and we want to multiply the whole thing by the texture size x, and we want to also calculate the position y, and instead of modulo we'll just divide it, an integer division will do. And we can just do position.x, position.y. Wait, the get pixel should be in the end. Now we need block width will be just texture size x, texture size y, and the colors. And we don't want to use the mid-level, we don't care. And that will add the textures, and we'll just do counter plus plus. And return, and what's the problem? Static, sorry, static. And that should be it. The only problem right now, or rather two problems, that one will be for later, is that, for example, our empty has an empty string. So first we wanna check if the file even exists. So if not file exists, path return. No, not return. Continue. Or there's a better way. What I mean by better? Oh, not a better way. Yeah, let's do it like that. Our texture can sometimes be a bit big for the amount we want, but we don't care. So that should be it, I think. Let's hope it should be it. So let's create some basic textures. Let's make them 16 by 16. Let's zoom in. I'll just do a simple, really simple texture. So let's do it like a whitish, like that with an iron. Let's make the border a bit border 1 a bit darker, like that, and just create a circle that will be darker as well, and that will be our iron. So let's save it. Control Shift P, I think, yeah. Desktop D project Voxel. You can see a project Solo and Arachne. I will show it later. So this will be iron hull. Export it. Now we can change the brightness and contrast to get more contrast, less. Oh wait, right, that like that. Shouldn't be darker. Wait, let's just do this manually. So let's add another layer. New layer, the same width and height. Let's do opacity 40, and let's make it black. Let's get the selection, and now black. And we can just manipulate the opacity of the layer to get a darker image. Yeah, 70 seems okay. Now let's merge it down to one layer, and now boost up the contrast and a bit of the bright. Now maybe the bright is okay, like that. And this will be our steel hull. And also we need a cobalt. So we'll just reverse, and instead of dark, we'll just do a bluish one. Maybe not that blue, more like that blue, and a bit darker. It is okay. It will be okay. And just do a cobalt hull. And we have all the textures. Now let's see if our algorithm works. I hope it will work. We need to just create the steel hull. I'll just do it by duplicating the iron hull and just change it here. Because that's the only change. Okay, So now let's see if it works. Now in voxel map we also need to do voxel texture helper dot create texture map. I know that it won't do anything for us visually, but we'll just check if there are errors. That's the only thing I want to check. There are no errors. That's good, I think. Okay, now let's apply the textures. So let's go to voxel base. Oh, you need to get texture. Right, we have the map, but we don't have any way to get the actual UVs of it. So we'll just do another public static void. No, not a void. enumerable of. And no enumerable. I just want a vector to get base UV, and we'll get a voxel type. And we need to somehow get a link between the type and the UV. So let's just do let's just make a private dictionary, private static dictionary of voxel type and vector 2. Sorry. And this just will be like that. So this will be UVs equals new, and we'll just do UVs dot add, and voxel type will be voxel dot type, and then the value will be position x divided by voxel texture dot width, and we need to wrap it in a new vector 3. I forgot about it. New vector 2, and this will just be a position y divided by voxel texture dot height. And now we can just do return UVs of type. Yeah, that should be it. So now we can go to voxel base and do data dot UVs. Oh, we can get a base UV. So var base UV equals voxel texture helper dot get base UV of type, because we know the type. And then we can just add range and just do a base UV plus something, new vector two. And the problem is that obviously that we don't know the exact sizes, so we need to go to this class and also do a public static vector 2 up offset. We just get and private set, and do the same for right offset. And we can set them here. The up offset is oh, we know them. Texture. No, we don't know them. We don't know them. Is up offset is new vector to 1f divided by size, and right offset up is this and right is that. It's 1 divided by size because it will be texture size divided by the whole thing. So I just skip the texture size y, texture size x, because it doesn't matter. So voxel texture helper dot offset up. This will be offset up and offset right offset, and this will be just right offset. This is the base UVs. So for example, they don't work for Cobalt Hull. Right now we can change it by adding this here. And that should work, I think. No, the given key was not present in dictionary. This will just be a voxel type.cobalt Hull. Okay, the first point, the first thing will be just for each let's just print every path that it encounters. So debug.log path. Textures.cobalt Hull. Okay. I think that's just. Oh, it has overloads. So I think that's just Unity being stupid. I can just do path dot because the problem is that the path.combine uses one slashes and the data path uses another type of slashes. So I can just do replace. And I can change this. Oh, char is a char. I can change this to this. I use double because one slash is an escape character. That means that, for example, if you want to add a or slash or something like that, a special character, they are good now. Okay, it wouldn't work. Okay, so the key was still not present. Let's see if it will print here. No. So for some reason it just says no, it doesn't exist. This file doesn't exist. Let's see. If I'm just it's inside assets. That's why I want to do path.get direction name. because this data path points to assets, and I want to go one folder up, and the gate direction name means go one up. And now it will all works, except it doesn't because I didn't apply the texture. So now I need to do voxel helper, no, not voxel helper, voxel texture helper, because I'm not setting this texture right now, so I can just do public texture 2D texture map, let's say, call it texture map get private set, and I can just do this, and it will use this one. Stop it. Like that. And I can then just go to chunk, and in the create chunk I can just do, I can create a new material, so va material equals this. I can do material.texture set texture or texture main texture equals voxel texture helper dot texture map, and just set material, and it complains that I can do it better. Yeah, like that, and that should work, I hope. No, it doesn't for some reason. Can I view this texture? For some reason this texture is not working. Oh, I know why it's not working. I can fix it right now. There is a magical function that you need to use, texture.apply, after every change. So texture texture map.apply, and it's the it's the worst, because it will change the pixels but it won't be showing the pixel, and it's working beautiful. Obviously it's blurry, we can also change that, so we can, in this type we can do texture format dot ARGB. Which one we want? I think the basic one. And we also can change something about the texture. I forgot what exactly. So without this, texture map dot wrap mode no, texel size no, filter mode equals filter mode dot point, and that will make the texture pixelized, because right now it's meant for this. You could no problem load a texture 1024 by 1024, but I want a look like that. So yes, we have our better voxel and texture management, and it works absolutely perfectly. We can create a better models, we can add textures, we can add multiple texture. We forgot about multiple textures, because some voxels will want to have a texture on the top. For example, I want one on the top green, on the bottom red, and size would be yellow. Or any other example, like I don't know if you ever played Minecraft. I mention this game every stream, but It's like the perfect example for voxel-based game, and was the one of the predecessors of the voxel-based game. There are types of blocks that connect to each other when they are when they are beside each other. So, for example, you would want a texture not connected at all like this, and a texture of connected. So, in the next stream, I think that's the end of the project. This is absolutely a good base for any game that we want to create. We have placing, we have textures, and a lot of things. Oh. What is that? What am I placing? What am I placing? Iron hole. And I think that's the texture of cobalt. Iron hole. We are not in the end. Let's check it. Let's use a iron hole. Okay, I'll fix it real quick. You can watch, but you can also listen to me. That's the end, I think, of the project. When I fix that. But I still want to do some things to this project. For example, show you how to make some crazy things, like linking the linking objects when they are beside each other, or multiple textures. They are completely not necessary for nearly any game. Maybe can multiple textures, but still, you could live without it. But if you are only wanted to do the base, this is the base. Go to GitHub, download it, and play with it as much as you want. There is a license on the GitHub. It basically says you have to link me and have the same license or something like that. You can read it. There is a simple explanation at the top. Whatever. But now let's fix that, because I don't like the fact that it doesn't work. So let's do a quick debug. So let's go to Voxel map and let's print. Let's print voxel helper texture helper dot get base uv voxel type dot steel hull, and the same for the others. So cobalt hull and iron hull. They are all 0, 0. I just assume it's UV. Position X in int. This is an int. So that's just a problem with this. Let's fix it. Just the division, that inter division. Yeah, we have it working. Nice. So let's just remove the debugs and let's check if it's all working. So let's do a 2 of cobalt and a 3 of iron. Good, we caught that. Is everything iron now? So that's what? Iron, okay. That's cobalt. Oh, there's a, as you can see, this is a cobalt and it's an iron, doesn't replace the iron. I don't like that. Okay, we know the position that the 0, 0, 0 should be iron, and it's not. So let's debug what type of it is. Debug.log this of voxel, yeah, dot 0, and let's debug the type. If it's iron, that means we have a problem with rendering. If it's cobalt, that means we have a problem with, it's iron, so we have a problem with rendering. So let's see what the problem is. When we set the voxel, we set it here. Okay. Chunk. Set voxel. If it's inside chunk, okay, that's good. That's good. Maybe this is the problem. No, because it's setting. So it definitely is setting this, but it's just not rendering it. Create voxel. World position. Okay, a tuple. It gets the position. That's good. Check the direction. Check the neighbor. Okay, let's just check. Oh, I know what it is. Okay, I know. So when we set the voxel, we need to remove its voxel render data. Why? Because the old render data contains the old voxel, but it only checks if it's there. It never removes the whole voxel render data. So we need to, instead of doing this, okay, we have to do this also, but we have to set the voxel itself. So voxel render data of remove position, and that should fix it. I hope. And we can just check if it's there. So voxel render data contains key position, and that should fix it. I hope. Yeah, it renders correctly now. So as you can see, everything is working. That's great. We can also check with a bigger set. Yes, everything is working perfectly. Yeah, perfectly. I had to double check. So yes, the project is finished. I'm glad how it came out. It wasn't much Google, and I'm happy about it. You can check out YouTube if you missed anything, any stream. I will manage to add the link to YouTube and GitHub sometime in some time. You can also check GitHub for the code, and I probably won't have time on Monday, and I will definitely not have time on Tuesday, so we'll see about the streams. Maybe I'll squeeze one on Monday, but I'm not sure. So that's it, I think. Goodbye, and check out GitHub in the link that will be there in 10 minutes, I hope.